All right, welcome everyone to our second International System Safety Workshop. I'm John Sloan from the U.S. Federal Aviation Administration's Office of Commercial Space Transportation. And as a reminder, if you have questions during the presentation, be sure and type them into the chat feature at the bottom of the screen. And today's speaker is Dave from our System Safety Branch. And let's get started. Dave, over to you.
Thank you, John. Next slide, please. All right. Hello, everyone, and thank you for participating in today's workshop on Part 450 System Safety. And on Tuesday, day one of the workshop series, we discussed the 450-103 System Safety Program Regulation. Today, we're going to discuss the 450-107 Hazard Control Strategies, and specifically, we will talk about the functional hazard analysis. And we are going to also walk through a template of the functional hazard analysis for 450-107. We also have two more workshops next week that we'll talk about, where we will talk about the remaining regulations for Part 450 System Safety. Next slide, please. So, sorry, could we please go back one slide? Thank you. Before we start diving into the details of 450-107, I'd like to actually first start out with an overview of 107. 107 Hazard Control Strategies. It is the heart of Part 450 because Part 450 regulation was designed to be a performance-based regulation. And it was designed to be applicable for the licensing of expendable launch vehicles, reusable launch vehicles, and reentry vehicles. So 450 is not a prescriptive regulation. Rather, it's a performance-based regulation that provides flexibility to the applicant to be able to document the necessary compliance data for various different types of vehicle designs and ensure public safety. And this requires a combination of system safety analysis, flight safety analysis, that's the FSA, and operational restrictions. So this is where 107 Hazard Control Strategies is very critical because 107 defines the applicability of other Part 450 regulations. And 107 also defines the scope and the level of rigor and the amount of effort required for certain analyses within Part 450 and some of the regulations within 450. So with that overview, let's start discussing the specifics of 107. Next slide, please. Thank you. 107A specifically requires that to meet the safety criteria of 101A, B, or C for the flight or any phase of flight, any particular phase of flight of a launch or reentry vehicle, the operator must utilize at least one or possibly more hazard control strategies as identified in 108 through 111. And actually, in the next slide, we're going to discuss in more detail what these four approved hazard control strategies are. And I'd also like to mention here that 101A and B, those are the launch and reentry public risk criteria, and 101C is the high consequence event protection criteria, and these are related to the flight safety analysis. 107B hazard control strategy determination specifically requires that for each phase of flight during a launch or reentry, an operator must utilize a functional hazard analysis to determine the hazard control strategy or multiple hazard control strategies. And the FAA requires that applicants document in their functional hazard analysis these three things. That is, that all functional failures that are associated with reasonably foreseeable hazardous events that have the capability to create a hazard to the public, those should be documented in the functional hazard analysis, along with all safety critical systems and a timeline of all safety critical events. So the takeaway here is that all applicants under Part 450 are required to document a functional hazard analysis in order to determine the hazard control strategies. And 107A particularly provides flexibility to the applicant that in order to assure public safety, for any given functional failure, the applicant may utilize either different hazard control strategies during different phases of flight, or as necessary, the applicant may utilize multiple hazard control strategies for a particular phase of flight of a given functional failure in order to assure public safety. Okay, next slide, please. So here we talk about the 4 different types of approved hazard control strategies under Part 450. And one thing I'd like to mention here is that as we walk through this presentation, we will also reference various sections from the AC for 450-107. And so it is this presentation follows sequentially through the AC. Now, the 4 different types of approved hazard control strategies are 450-108 flight abort, 109 flight hazard analysis, 110 physical containment, and 111 wind waiting. So 108 flight abort, this is your traditional safety approach for expendable launch vehicles. And basically it's a process. It's the process by which the applicant limits or restricts the hazards to the public safety and to the safety of property. And this is done so by, during the flight, initiating and accomplishing a controlled ending to vehicle flight. So essentially, 450-108 flight abort is the hazard control strategy that utilizes flight safety systems and flight safety analysis in order to assure public safety. 109 flight hazard analysis is a second type of approved hazard control strategy, and this is the system safety centric approach. And it has traditionally been utilized for reusable launch vehicles. And 109 flight hazard analysis is the most flexible type of hazard control strategy because for an applicant that has a unique launch or reentry vehicle system design or a unique operations concept, 109 allows the applicant to derive specific hazard controls for that unique design or operations concept. Now, under 450, ELV and RLV operators are able to utilize either 108 flight abort or 109 flight hazard analysis, or both hazard control strategies as needed to assure public safety. The third type of approved hazard control strategy is 110 physical containment, and this hazard control strategy is normally utilized for low energy test flights, where the launch vehicle does not have sufficient energy for any hazards that are associated with the flight to reach the public or any critical assets. And 111 wind waiting is traditionally utilized in the launch of unguided suborbital launch vehicles, also known as sounding rockets, where the launcher azimuth and elevation settings are adjusted to correct for the effects of wind conditions at the time of flight in order to provide a safe impact location for the launch vehicle or its components. So the takeaway here is that in the functional hazard analysis, all applicants are required to identify at least one or multiple hazard control strategies, choosing from one of these 4 approved hazard control strategies for each functional failure during the flight or a particular phase of flight as necessary to assure public safety. Next slide, please. Okay, so section 6.2.1 of the AC talks about the 5 purposes of the functional hazard analysis. And as I mentioned earlier, 107 is the heart of Part 450, and the functional hazard analysis is a very critical element in ensuring public safety during the flight. This is because the functional hazard analysis is a foundational analysis that provides a holistic and a systematic approach to identifying potential hazards to the public, and it also supports the validation of adequacy for the determined hazard control strategies. The functional hazard analysis supports a justification for the use of historical flight outcome data in accordance with, for the probability of failure analysis in accordance with 131. And it supports as the basis for developing the quantitative models of debris in accordance with 451.21 and the malfunction trajectories in accordance with 119. And I'd like to mention here that 131, 121, and 119, those are part of the flight safety analysis, FSA. Lastly, the functional hazard analysis is the very basis for the development of the flight hazard analysis. So recall from our earlier slide, one of the 4 hazard control strategies approved under 450 is 109 flight hazard analysis. So when an applicant is deciding to utilize the 109 flight hazard analysis hazard control strategy, in that case, the applicant would take the data that is documented in the 107 functional hazard analysis and then expand on that data in the flight hazard analysis under 109. And we actually have a workshop next week where we will do a deep dive on 450-109 flight hazard analysis. I believe it is on Tuesday, May 16th. Next slide, please. Okay, so now I mentioned earlier that the applicants have the flexibility under 450 to determine different types of hazard control strategies for different phases of flight or multiple hazard control strategies for a particular phase of flight. But there are 2 constraints to the hazard control strategy determination. The first is that as per 450-107C, in a situation where the applicant is looking to utilize either physical containment, wind weighting, or the flight abort hazard control strategy, but the applicant is not able to demonstrate that the public safety hazards are adequately mitigated to meet the public risk criteria for 101A, B, and C, then in that case, 107C explicitly requires that the applicant must conduct a flight hazard analysis per 109 for either the entire flight or that particular phase of flight as needed to assure public safety. The other constraint here is that in accordance with 101C, that is the high consequence event protection, if the consequence of any reasonably foreseeable failure mode in any significant period of flight is greater than 1 × 10⁻³ conditional expected casualties, or often known as CEC, then flight abort hazard control strategy, that is the 108 flight abort hazard control strategy, must be utilized and the requirements of 108 must be satisfied, or the launch or reentry vehicle must have sufficient demonstrated reliability as agreed to by the FAA administrator based on the CEC during that phase of flight. And we do have an AC on 450-101 high consequence event protection that provides additional guidance on CEC. Okay, let's move to the next slide, please. Okay, so here in section 6.2.3 of the AC, we talk about the hazard control strategy determination logic, and there is a figure in the AC that outlines the overall process. It's a process flow chart for determining the hazard control strategy. And on this slide, we start out with the beginning portion of the logic diagram, which is at the program design level. And generally here, the applicant will determine the hazard control strategy based on 2 factors. The first is engineering judgment and experience with similar vehicles in combination with the program considerations. So that may be preferences, cost and schedule, design selection, or concept of operations. So these 2 factors will then feed into the applicant's initially postulated hazard control strategy or multiple strategies. And on Tuesday, during day 1 of the workshop series, we talked about 450-103 system safety program. And in there, we talked about how per 103B, applicants are explicitly required to document their processes and plans for hazard management. And this includes the development, implementing, and maintaining of the functional hazard analysis. So moving forward in this process flowchart, if the hazards to the public that result from a functional failure during either the entire flight or a phase of flight is not potentially mitigated, then in that case, as we see here with the arrow pointing back, the feedback loop, the applicant is required to revisit the initially postulated hazard control strategy in order to assure public safety. So the key takeaway here is that the approach for determining and validating hazard control strategies, it is a iterative process. And with that, if the applicant finds that the hazards to the public resulting from a functional failure during the flight or a phase of flight are in fact potentially mitigated, well, in that case, we would move forward in this process. So let's go to the next slide, please. Okay, so now moving forward to the system design and analysis portion of this logic diagram. And we see here that there is an arrow coming in from the top right corner of the image, and it goes to two locations on this flowchart. If the hazards to the public are potentially mitigated, then the selected hazard control strategies are then further developed, and the supporting data is used as general input for the flight safety analysis. Now, with respect to developing strategies further, on this flowchart, we identified the corresponding regulations that need to be satisfied by the applicant based on the selected hazard control strategy. And again, it's important to note here that the malfunction trajectory analysis per 119, the probability of failure analysis per 131, and the debris analysis per 121, they are part of the FSA, the flight safety analysis, but they are very critical aspects of this process to assuring public safety. So moving forward in this flowchart, the functional hazard analysis should be reviewed and revised based on the hazard control strategy that is selected and the supporting data, which includes the flight safety analysis data. And if the mitigation is not validated by the supporting data, then again, there is a feedback loop where the hazard control strategy needs to be revisited or the methodologies need to be updated for the selected hazard control strategy. If there is successful validation, then the flight safety analysis is utilized to demonstrate whether the safety criteria for 101 A, B, and C are satisfied. But if the safety criteria are not met, and then in that case, additional hazard controls must be implemented, and that is in accordance with 107C. Next slide, please. Okay, so we already talked about 107B hazard control strategy determination, but the key takeaways here are that one of the reasons why the FAA generally recommends applicants to complete the functional hazard analysis as early as possible in the launch or reentry system's life cycle is because by the applicant conducting the functional hazard analysis and following the systematic process that is the system safety process, the applicant may realize that there is a need to change either the vehicle system design or the operating concept in order to assure public safety. And in that case, it would be beneficial for the applicant to identify and mitigate such public safety concerns as early as possible in the program lifecycle so as to reduce any potential program impacts. The functional hazard analysis is also utilized to analyze the system functions associated with the operating concept. And it's important to note here that the term reasonably foreseeable is not associated with the probability or the likelihood, but rather it is inherent to a methodical assessment of the entire system. And moreover, the reasonably foreseeable hazardous events are those that are identifiable through the system safety process, but they are beyond those that could be determined solely by brainstorming. So while brainstorming is a good first step, but following the system safety process will likely identify other potential reasonably foreseeable hazardous events and hazards to the public and safety critical systems that may not always be apparent through just brainstorming. Okay, next slide, please. Okay, so section 7.1 of the functional hazard analysis, of the AC for 450-107 talks about the functional hazard analysis, and specifically it identifies that the functional hazard analysis is primarily used to identify and classify the overall system functions and the consequences of the functional failures or malfunction. And the objective here is to identify all potential system, subsystem, and component functional failures that could impact the public safety. And something to note here is that an assessment of the hazards to the public is done at the system mission level. Also, any foreseeable mitigations or predetermined hazard control strategies should not affect the identification of potential system safety hazards and respective functional sources, such as subsystem functional sources or maybe component level functional sources. And we'll actually talk more about this when we go through the template for the functional hazard analysis in a later slide. So prior to performing a functional hazard analysis, the FAA recommends that the operator should have sufficient understanding of the overall mission, because that will support the applicant in identifying accurately all functional failures, as well as traceability to the FSA data and hazards to the public. I'd like to mention here that there is an AC for 450-107, but there is a revision to the AC coming out, and it's currently in the release process. And that update to the AC is going to include an updated template for the functional hazard analysis. Now, because it's in the release process, it is not currently available on the FAA website. Once the AC with the template is released, we will post that on the FAA website. However, in the meantime, we are actually going to walk through the updated version of the template for the functional hazard analysis. Next slide, please. Section 7.2 of the AC talks about the accuracy and the adequacy of the flight safety analysis. And particularly, it says that as per 451.13a, the applicant is required to perform the FSA and document, and it should be done for all phases of flight, except as specified in 113b regarding demonstrated reliability. Also, the functional hazard analysis is essential for ensuring that all potential functional hazards are captured in the FSA, which in turn assists in assessment of the end effect. So what this means is that there is data that flows from the functional hazard analysis to the FSA, and this data from the functional informs the development of the FSA. And likewise, there's data that flows back from the flight safety analysis, and it informs the development of the functional hazard analysis. So the key takeaway here is that both the functional hazard analysis and the flight safety analysis are independent but interrelated analyses, and both analyses should be aligned. If the two analyses are not aligned, then that means that there is potentially a traceability data gap. And in that case, the applicant would be required to fix the traceability data gap in order to assure public safety. Also, the assistance from the initial FSA data supports the accuracy of the functional hazard analysis by identifying which functional hazards are truly system mission level hazards to the public. Great, next slide, please. Now, in section 7.3 of the AC, it talks a little bit about the three primary outputs of the functional hazard analysis, and we already covered a lot of this, but I want to mention that in the next slide, we're actually going to expand further on the second point, that is the identification of safety critical systems. So let's go to the next slide. Now, this is an important slide because it talks about the definition of safety critical. And I'd like to mention that under 450, the FAA has not changed the definition of safety critical for the public. Per 401.7, safety critical is defined as essential to the safe performance or operation. And any safety critical system, subsystem, component, condition, event, operation, process, or item is one whose proper recognition, control, performance, or tolerance is essential to ensuring public safety and the safety of property. Now, this definition in 401.7 is aligned with the definition of safety critical in MIL Standard 882E. And as described in the preamble for Part 450, the key takeaway here is that if the failure of a system can create a hazard to the public, and this includes waterborne vessels and air traffic, then that system is a safety critical system. So basically what this means is that any system, subsystem, component, or item is public safety critical if it could either create a hazard to the public or contribute to a hazard to the public or mitigate a hazard to the public. Another important point to note here is when identifying potential hazards to the public, the FAA requires applicants to not consider potential mitigations or hazard control strategies. So the identification of functional failures and potentially that could potentially result in a hazard to the public and the identification of safety critical systems are independent of any mitigations. The reason for this is through the methodical and systematic process, the applicant is required to document the functional hazard analysis and to identify all potential credible hazards to the public. And then the applicant is required to map those potential hazards to the public to the applicable hazard control strategies, or if the applicant has selected to utilize the 450-109 flight hazard analysis hazard control strategy, that then map to the derived mitigations that result from the 109 flight hazard analysis. Okay, let's go to the next slide, please. Now, in the preamble for Part 450, there is a great description on the intent of the regulations. And specifically, I'd like to point out here that the system safety analysis under 450 is used to identify public safety critical systems and to guide the application and the level of rigor of other Part 450 system safety critical requirements. And specifically, I'd like to mention here that the applicant's identification of and the proper management of safety critical systems is fundamental to mitigating potential hazards and ensuring public safety. And any vulnerabilities of safety critical systems must be accounted for in the flight commit criteria, the hazard analyses, the lightning protection criteria, management of radio frequency to prevent interference, and the communications plans. Next slide, please. Okay, so here there is an image of the 450-107 functional hazard analysis template. And before we start talking and walking through the functional hazard analysis, I'd like to mention a few things here. The process for determining and validating the hazard control strategies includes, first, the applicant having a full understanding of the system and the operations concept, and then documenting a functional hazard analysis and integrating that functional hazard analysis with the FSA data to ensure the accuracy and the adequacy of both the functional hazard analysis and the FSA data. Then the applicant is required to identify the hazard control strategy for each phase of flight. And lastly, to validate the adequacy of the determined hazard control strategy. And as we noted earlier, this is a continuous and iterative process. So with that, we've covered the functional hazard analysis at a top level. And at this time, I'd like to request if we can please stop sharing the slides, and I will open up the PDF and we will walk through the functional hazard analysis. Can I please get a confirmation that you are able to see the functional hazard analysis template?
We can see it. Yes, thanks, Dave.
Perfect. Thank you, Pam.
Mhm.
So I'd just like to mention here that this is the updated template for the functional hazard analysis. And currently it is still in the release process. So we have it with a watermark here for draft. Once the revision A for the AC for 450-107, along with the appendix A of this template is released, we will post this on the FAA website. And I'd just also like to mention here that this is one method for the applicant to document the required traceability data, but not the only method. Specifically, we chose the tabular format here because it allows for an applicant to clearly identify the system safety functional failures and map those failures from system safety data to the FSA data, to the hazards to the public, to the verification evidence, and to the computing system safety data. Now, let's start walking through this template. And the first four columns here, that's the top level system, next level system, subsystem, and component columns. These columns are where the applicant will perform a full breakdown of their unique system design and operations concept. As I mentioned earlier, the functional hazard analysis is required for all applicants. And so this includes for ELV, RLV, and re-entry vehicle operators. So the functional hazard analysis is designed to provide flexibility and allows for the assessment of various types of vehicle system. And that's why this is where the applicant will create their own breakdown of their vehicle system, starting with the top level system, which would be what they're applying for a license. So the top level system, and then they will continue forward by identifying all of the next level systems that would be, for example, a launch vehicle might have multiple stages. So the example here is launch vehicle stage 1. In stage 2, the applicant might also identify the spacecraft or the modules of the spacecraft and payloads as well. Once the next level systems are identified, the applicant will then document the subsystems for each next level system. And the example for provided here is avionics systems, propulsion subsystems, control subsystems, flight safety system, and so on. And what we mean by so on is due to the various different types of designs that an applicant might have. it's not possible for the FAA to document all potential types of subsystems in this one template or one page. So we require that the applicant, for their unique vehicle system design, will break down their system into all of the subsystems and then next into their major components. Now, something I'd like to mention here is for the major components, the FAA requires applicants to break down the system to the appropriate level such that the applicant is able to identify all functions that are necessary to be performed during the license operations, as well as identify all of the functional sources, functional failure sources. So this means that going down to the printed circuit board assembly level, the PCBA level, or the piece part level may not always be necessary for all components. But let's say that if the functional failure source is at that lower level, at the PCBA or piece part level, then in that case, on a case-by-case basis, it may be necessary for the applicant to go down to the PCBA or the piece part level. And so the key takeaway here is that the FAA requires applicants to break down their vehicle systems to a reasonable extent as necessary to assure public safety. And if one of the hazard control strategies that we discussed was 45109, flight hazard analysis. So if the applicant is utilizing 109, then on a case-by-case basis, it may be necessary for the applicant to go down to the PCB or piece part level if those unique derived mitigations identified in the flight hazard analysis are actually at that lower level. So if the design mitigation is implemented at the PCB or piece part level, then you have to break down the system from a major component level to the next level next level component. Now, if this breakdown of the vehicle system to its subsystems and components and lower level items is done appropriately, then that will make the job easier for the applicant to identify all potential functions for each major component or the lower level items. So the example here is for the component of a computer, where for the avionics subsystem, the applicant might identify a computer that computes and guides the trajectory of the flight vehicle, or another example is batteries. And for the propulsion subsystem, engines, control subsystems, RCS, and FSS, the flight safety system, safe and arm. So for each of these components, major components or the lower level items, the applicant will then identify each function that is necessary to be performed during the license operation, and then identify the implementation method for each function. So some common examples of implementation methods are hardware, software, firmware, and discrete logic. And we'll actually get back to this in the last two columns at the end of this template. The next column that we have is the function ID. And here the applicant will document the functional ID because it helps with creating traceability from each function to the associated hazards to the public and to the FSA data, to the hazard control strategy, and to verification evidence documentation. So traceability is very important in system safety and specifically in Part 450, because it allows for a way to track this mapping from the system safety data to the FSA throughout the program lifecycle. And so let's say that throughout the program lifecycle, the design of the vehicle subsystem or the component changes or the function changes, then any hazards to the public, they may be impacted. So we require applicants to create a function ID that allows to clearly trace any impacts to the hazards to the public. Next, for each function, the applicant is required to identify the phases of flight that the function would be carried out in during the license operation. And some examples here are launch, ascent, abort, reentry, and landing. Now, it's important to note that this is not an all-inclusive list. There may be certain unique phases of flight that the applicant needs to document in their functional hazard analysis based on any unique system design or operations concept. So if there is a certain phase of flight that is not covered in this template, then the applicant should document it in their functional. I'd also like to mention that there are flight safety analysis ACs, and in those FSA ACs, the FAA describes key flight safety events. And the use of those key flight safety events for the definition of phases of flight in the FSA. Now, generally, the system safety phases of flight, as documented in this functional hazard analysis, should be aligned with the FSA phases of flight. But as we see, there is a note here. And so let's go to that note at the bottom, which says that multiple phases of flight, as defined in the AC 450-101-1, may be combined into a single phase of flight for the purposes of system safety analysis, as long as the configuration of system does not change. So what this means that, let's take, for example, the ascent phase of flight. The FSA might break this phase of flight into smaller parts based on the time post liftoff. But for the purposes of system safety and the functional hazard analysis, those may be grouped into one phase of flight called ascent. Next, the applicant will then document the different mechanisms for each function. And note that the title here is not failure mechanism, it's just mechanism, because in this updated version of the template, the FAA has added one more type of mechanism that is functions properly. The reason we have added this is because, let's say for a launch vehicle, one of the necessary operations is fairing separation. Well, that is an intended operation, it's not a failure. But the fairing separation may present a hazard to the public, depending on where the expected impact locations of the fairing might be. So we require the applicant to document all potential hazards to the public. Now, again, this is not a all-inclusive list. This is an example of different mechanisms. There might be unique mechanisms that apply based on a unique system design or operations concept for a particular applicant. But the common mechanisms are functions properly, failure to function, functions early or late, functions out of sequence or out of time, functions inadvertently, or degraded function or malfunction. Once the applicant has identified all of the functions and the mechanisms associated with those, then the next step is to assess the end effect of those functional failures. And here I'd like to mention that, again, the FAA requires applicants to not consider mitigations or hazard control strategies when the applicant is assessing the end effect of a functional failure or the hazard or the corresponding hazards to the public. Now, based on the functional failures, again, there is a column here for the functional hazard ID, because traceability is very important. And here, this specific column will support mapping from each functional failure from system safety data to the hazards to the public and to the FSA data and to the computing system safety data. And this can be tracked again throughout the program lifecycle to assess for any impacts to the hazards to the public based on any changes to the vehicle system design. Something to note here is that the title also says NSI. So let's say that a particular functional failure mechanism during a phase of flight may result in a hazard that is a mission hazard, but it is not a public safety hazard. There is no impact to the public. Then in that case, the applicant will identify NSI, which means no safety impact. For any functional failures during a particular phase of flight, if there is a potential hazard to the public, then in that case, the applicant will then identify the severity of the hazards to the public. And again, the FAA requires applicants to not consider mitigations when identifying the severity of the hazards to the public. Currently, system safety process the Part 450 system safety process does not have a way to separate out critical or lesser severity hazards to the public. So at this time, the FAA requires applicants to identify all potential hazards to the public, such as debris hazards, as catastrophic hazards. Once the applicant has identified the severity of the hazard, then at this point, this is really everything up to the severity column. From the left of this template up to the severity column is all system safety data. From the right here, from the FSA failure mode column up to the right of and at the end of this template, this is where the applicant will perform the traceability from the system safety data to the FSA and to the verification evidence, the hazard control strategies, and the computing system safety items. Now, the first two columns we have here are the FSA failure mode and the FSA failure response mode columns. So this is, let's take, for example, the system safety functional failure of a thrust vector control actuator failing due to any particular cause. For a TVC actuator failure, the applicant may map that failure to, for example, an off-nominal trajectory failure that results in a malfunction turn vehicle response. So that is the type of data that should be populated in these two columns by the applicant for each functional failure during each phase of flight that could present a hazard to the public. And that leads us to the next column, which is potential hazard to the public. And here, again, as I mentioned earlier, the hazards to the public are assessed at the system mission level, and it should not account for any mitigations or hazard control strategies. So for the earlier example, continuing with the earlier example of a TVC actuator failure that results in off-nominal trajectory and malfunction turn vehicle response. In this column here, the applicant may identify that such a failure could lead to intact impact and debris hazards, or other potential types of hazards might be DFO and toxic hazards. It is important to note here that it's the flight safety analysis that will inform the content in these three columns: the FSA failure mode, FSA failure response mode, and the potential hazard to the public column. Once potential hazards to the public are identified, the applicant will then document the hazard control strategy. And as we walked through the process earlier, the applicant will first document the initially postulated hazard control strategy, but then based on feedback from the FSA data, the applicant will need to revisit and update the hazard control strategy or modify the methodologies of the selected hazard control strategy to assure public safety and to meet the risk criteria for 101A, B, and C. The next column we have is the verification evidence data column. And this is where the applicant will document in the compliance, all of the compliance data that validates the selected hazard control strategy. And we're actually going to talk a little bit more about the validation and the adequacy of the hazard control strategy in the next slides after we cover this template. The last two columns here, that is the 45141, the traceability to the 45141 computing system safety regulations. So this is the CSSI, that's computing system safety item degree of control, and the CSSI level of criticality. And this is where we go back to this implementation column. Any function where the applicant identifies either software, firmware, or discrete logic as the implementation method for that function. For each functional failure during any phase of flight that presents a hazard to the public, the applicant would then document the CSSI degree of control and the level of criticality, because this will inform the 45141 computing system safety regulation and the level of rigor necessary for that regulation. And next week, I believe that is day 4. So on Thursday of next week, we're going to do a deep dive of the 141 regulations. So that is the end of the template for 451-107 functional hazard analysis. And before I go back to the slides, I'd like to stop here and ask if there are any questions.
Thanks, Dave. I haven't seen any questions come into the chat, but just a reminder to everyone on the webinar today, the workshop today, to please use the chat function, which is at the bottom of your screen, to enter any questions. And with that, Dave, we could probably press on to the next part of your presentation.
Okay, thank you, Pam. So I'm going to stop sharing my screen and like to request if we can share the presentation again. I believe we will be starting on slide 17. Okay, thank you. So section 9 of the AC for 107 talks about hazard control strategy validation. And when we talk about the hazard control strategy validation, what we're saying is this is where the applicant will be closing out the system safety case. So as we discussed earlier, 107A requires that the safety criteria for 101A, B, and C must be met by using at least one or multiple hazard control strategies. So an applicant that is looking to utilize either physical containment, wind weighting, or flight abort as the hazard control strategy, there are three validation criteria that must be satisfied by the applicant in order to demonstrate that all public safety hazards are adequately mitigated and the public risk criteria for 101A, B, and C are met. And those three validation criteria are that the hazard control strategy should mitigate system safety hazards to the public, such that the likelihood of any hazardous condition that may cause death or serious injury to the public is extremely remote. And again, assessing the hazards to the public and the likelihood of any hazards to the public is done at the system mission level. The hazards and hazard control strategies are characterized with should be characterized with the level of fidelity that is commensurate with the flight safety analysis per 115B, such that they are valid for use in debris data development in accordance with 121, malfunction trajectory analysis in accordance with 119, and consistent with the probability of failure analysis in 131. And the flight safety analysis that is utilizing the hazard control strategy of either physical containment, wind rating, or flight abort. That flight safety analysis must satisfy the safety criteria of 101A, B, and C. So if an operator that is utilizing this means of compliance is unable to demonstrate the 3 validation criteria above for any of those 3 hazard control strategies, then the operator would need to perform a flight hazard analysis in accordance with 107C, or utilize another means of compliance to demonstrate the hazard control strategy adequately mitigates the hazard to the public. Next slide, please. Okay, so now let's talk about the adequacy of the determined hazard control strategy. And specifically, there is, this is described in sections 9.1 of the AC, where it identifies 6 different types of sources of compliance data that can be utilized by the applicant to support the validation of the adequacy of hazard control strategy. And on this slide, we have 4 of those 6, and we'll talk about the next 2 in the next slide. But the first 4 are flight safety analysis data, flight hazard analysis data, computing systems data, and the safety critical systems design, test, and documentation data. So for flight safety analysis data, assistance from the initial FSA is important for identifying the system and mission hazards to the public. And the FSA data should assist in understanding the effectiveness of mitigations. The final FSA should also inform the validation of any hazard control strategy for a phase of flight. So any of the 4 approved hazard control strategies, the applicant can leverage data, compliance data from the flight safety analysis. If the 450-109 flight hazard analysis hazard control strategy is determined by the applicant, then the compliance data that results from 109 can be utilized by the applicant for validation of the flight hazard analysis strategy for each phase of flight where they determine 109 is necessary to assure public safety. And there is an AC that the FAA has released on 450-109 that provides further guidance on the flight hazard analysis. And we're actually going to talk more about that in depth on Tuesday of next week during the workshop, day 3. Computing system safety data is always required. And the data that is compliance data that is resulting from 450-141 can be utilized by the applicant for the validation of either the flight abort hazard control strategy or the flight hazard analysis strategy for each phase of flight where it is utilized. So there is an AC also on 450-141 that provides further guidance on computing systems and software safety. And again, that is going to be our topic for the day 4 of the workshop series. The 4th type is safety critical system design, test, and documentation data, which is from 450-143. So the compliance data from 143 can be utilized by the applicant to support the validation of a flight abort or the flight hazard analysis strategy for each phase of flight where either of those 2 hazard control strategies are utilized. Now, I'd like to mention here that right at this time, the AC for 450-143 is in work. For non-FSS safety critical systems. So it is not currently released and available on the FAA website. Next slide, please. Okay, so the last 2 types of sources for compliance data that support the validation of the adequacy of a hazard control strategy is highly reliable FSS, flight safety system data, per 145 or wind weighting safety system design, test, and documentation data per 111. So for the highly reliable FSS data, compliance data from 145 can be utilized by the applicant to support the validation of a flight abort hazard control strategy for each phase of flight where 108 is utilized to assure public safety. And similarly, for 111, when weighting, any compliance data for 111 can be utilized by the applicant to validate the adequacy of a wind weighting strategy for each phase of flight where 111 is utilized. Okay, next slide, please. Okay, so now 107D, that is the application requirements, and specifically the applicant is required to submit in the application two things. First, the results of hazard control strategy determination, and this should always include all functional failures identified under paragraph B1 of 107, as well as the identification of all safety critical systems and a timeline of all safety critical events. Also, the applicant should submit a description of its hazard control strategy or has multiple strategies, if utilized, for each phase of flight to assure public safety. And as I mentioned earlier, the revision A of the AC for 107 with the updated Appendix A template is currently in the release process, but once it is released, we will post that on the FAA website. Okay, next slide, please. All right, so to summarize, we talked about the determination of hazard control strategies from 108 through 111, and those are the 4 approved types of hazard control strategies. We also talked about the applicant conducting a 107 functional hazard analysis, and that the functional hazard analysis should document these 3 things, that is, all functional failures associated with reasonably foreseeable hazardous events that have the capability to create a hazard to the public. And the functional hazard analysis should also document all of the safety critical systems and a timeline of safety critical events. We also talked about the applicant conducting a 450-109 flight hazard analysis, especially if it is required by 107C. And we talked about the adequacy and the validation of the determined hazard control strategy or multiple strategies. Okay, next slide, please. Okay, so that is the end of 450-107 hazard control strategies topic. And at this time, if there are any questions, I will be happy to address them now.
Thanks, Dave. Great presentation today. Let me remind everybody, if you have any questions, to please use the chat function at the bottom of your screen. We are taking questions. We'll have our subject matter experts answer those as we can. So we'll pause here for a moment just in case people are typing right now. And while we're waiting to see if there's any questions, I'd like to remind everybody that we have 2 more sessions of the System Safety Workshop. They will be on Tuesday and Thursday of next week. You should have already seen information about the dates, times, and of course the link to join those as well. They will have the same format and participation for those. We appreciate any questions that you guys might have. I haven't seen any come through, so let me just make one last call for any questions. Okay, well, let me thank everybody for joining us today. I appreciate it. Thanks so much, Dave, for the very good presentation. I hope everyone has a very nice weekend, and we look forward to everyone joining next week on our 2 sessions next week. Thank you.
Thank you.